We can interpret the median value in another way. 50% of the values are less than the median, while 50% are above. So for example, if our values look something like this, the median is halfway between 10 and 20, so the median is 15, and we have 3 half the values less than 15, and 3 half the values more than 15. Actually, this isn't true because we might have a data set that looks something like this, and here the median is 10, and there are no values above the median, and very few values below the median. However, if x is a continuous random variable, then, in general, the probability that x is equal to any specific value is going to be 0. In that case, there's always a value where the probability that x is less than or equal to that value is 0.5. And again, since the probability that x is equal to any specific number is going to be 0, then the probability that x is strictly less is still 0.5. And this avoids the problematic cases of the median of a set of discrete values. So remember, math ever generalizes. We could use any fraction, suggesting the following. In a dataset, the pth percentile is a value that is greater than p% of all values. So, for example, suppose the waiting time for a train has a uniform distribution over the interval 0 to 30 minutes. Find the 70th percentile of the waiting time. So a uniform distribution over this interval will have PDF, and so its CDF will be and to find the 70th percentile, we want the probability that x is less than or equal to whatever that is to be 70%. And so solving that gives us or, for example, the cost of a wedding is exponentially distributed with mean of 15. Let's find the 90th percentile of wedding costs. So the PDF for an exponential distribution with mean 15 is, and so the CDF will be, the 90th percentile will solve the equation. The probability is 0.9, 90%, and so we find or suppose they lost from an accident that has a PDF that's proportional to for all non-negative x. Find the second percentile of the losses from accidents. So the proportionality tells us that the PDF is going to be some constant c times that rational expression. Well, it appears we need to know c, and we should probably find it for practice. Note that since x is non-negative, the probability that x is greater than or equal to 0 must be 1, and so the probability that we're between 0 and a is that probability divided by the probability we're greater than or equal to 0. And if we substitute our function in, note that the constants actually drop out at the price of picking up this integral. To evaluate the integrals, we'll use substitution because we can let u equal 1 plus x squared, and then du is going to be most of the rest of the expression, and so that gives us then substituting our limits of integration give us, and this actually gives us a general formula for our probability that we're between 0 and some upper value. So the second percentile satisfies this probability as 0.02. And so we want to solve the equation. And solving gives us